Video is going to serve the purpose for basically instruction or help for homework over sections 4-3 through 4-8 for Algebra 1 TXVA during the week of April 22nd through the 26th. This video is basically to supplement your reading and working through problems and taking notes from the different sections online. So what I'm going to do is I'm going to go through each section and I'm going to work some problems. I'm going to explain some things and work some examples of problems for each section. The first section we're going to start with is section 4-3, direct variation. Direct variation is a topic that is very important, and it looks very tricky when you're trying to look at it to figure out what's going on, but it's really just a matter of substituting and solving and then substituting again. What we have, first of all, if you recall, the point-slope form of the equation that we have been working with. This is the slope-intercept form of a line where m is the slope and b is the y-intercept. Well, if we'll notice this piece here, when the y-intercept b is equal to 0, looks a lot like this, except they're calling k is what we call the constant of variation. That's basically the slope of the line. So let's take a look at how these problems work. It says, writing and solving direct variation equations. It says, if y varies directly with x, and when it says this, all it means is you're going to use this, y equals kx, okay? And y is 30 when x is 6. Find the direct variation equation. Okay, that means we have to find k, this constant of variation. Well, if y is 30 when x is 6, my direct variation equation is y equals kx. So if y is 30, sub that in for y, equals k times x, and x is 6. So solve for k. Alright, so divide by 6 on each side because k and 6 were being multiplied. These cancel or becomes 1. So I have 1k, or just k, is equal to 30 divided by 6, which is 5. So k is 5. What that means is to write this equation for part A, you just have y equals kx, but I know that k is 5, so it's 5x. This is how you write that equation, the direct variation equation. Again, all I did was I took my direct variation equation, y equals kx. They gave me y and x. So now I just substitute the 6 in for the x, the 30 in for the y, and solve for k using my equation solving capabilities. Part B says find x when y is 25. All I do now is go into the equation that I found. We want to know what is x when y is 25, so we sub in 25 for y. 25 is equal to 5x, and we want to know what x is. So we solve for x, 5 and x being multiplied. We divide by 5. 5 divided by 5 is 1, so I have 1x, or just x, equals, divide this side by 5, and I get 5. So the answer for part B is x equals 5. So as you're watching this video, after you've read the sections, if you're still needing more help with this, just rewind it and go back and look at it again. But it's just a matter of using the equation, the direct variation equation, and to find the direct variation equation for this situation. Okay? You just sub in what y is and what x is, and then find k. So you need to remember that first you have to find k, given the x and the y, and then you just go from there. Hopefully you find that pretty easy. Let's move on. Section 4 is more about the slope-intercept form, and we've talked quite a bit over the last couple of weeks about slope-intercept form, but I still wanted to include some examples here because I just think it's good. Remember, we have the formula y equals mx plus b, and this is the slope-intercept form because we're given the slope, which is m, change my color, slope, which is m, and the y-intercept, which is b. That's what we call it, the slope-intercept form. So since we've worked with this form of the equation quite a bit, let's just work through these two examples. And I think they'll both serve as a good review. The first one is write an equation of the line that passes through this point and has a slope of -3. Well, what this tells me is, and I'm just going to kind of draw a line down here, I have y equals mx plus b, and definitely rewrite this every time you work these problems until you get very comfortable so you know exactly what you're working with, because we're doing a lot of substitution. So I know that m is my slope, which is -3. So right now I have y equals m, which is -3 times x plus b, my y-intercept. Now remember, I told you this last week or the week before, probably both, that when we're writing the equations in this form, the y and the x will be there. This y, this x will be in your equation. What you're going to be putting into the equation, you have to find values for m and b. Okay? So right now we have a value for m, but we don't have a value for b. But what we do have is a point that the line passes through, which means I have an x, y value. So what I want to do, if you'll notice here, I want to find what b is, and I have my m. Wonder what would happen if I substituted the y for y, the x for x, and solve for b. Well, what would happen is I would have an equation with a variable b that I could solve for. So x is 6, plug it in for x, just substituting it in there. Y is -2, plug it in. Now look what I have. I have an equation that has the variable b that I can solve for. First, I simplify with multiplication, bringing this -2 down. And I just put these parentheses here. You don't have to if you don't want to. I put them here so you can see that this is what y was. I'm just subbing in a -2 for the y. This is where x was. I'm just substituting in a 6 for the x. So I have -2 is equal to -3 times 6 is -18 plus b. 18 is being subtracted from the right side of the equal sign, so I add 18 to both sides. These cancel or become 0, and I get b is equal to positive 16, because -2 plus 18 is positive 16. So now what I have, go back to here where I had y equals -3x, and I needed my b. Well, what's my b? My b is 16. So this would be my answer. So notice, I still have my y and I have my x there. The only thing I did was put my m in place and my b in place. You're going to have this y and this x, and that's my answer. That's how I write an equation in slope-intercept form, giving a point and giving a slope. When I'm given the slope, I just plug it in directly, and then I put the x for x, the y for y, and solve for b. And kind of remember that. It kind of rolls off your tongue a little bit. X for x, y for y, solve for b. Okay, let's look at the second example. Now the second example is very similar to the first. The difference is, the first example I was given a point and a slope. Well, the second example I'm just given 2 points, which is fine because I can find my slope. Remember, I need y equals, got to find my m, x plus, got to find my b. Well, how am I going to find my m, my slope, if I don't have a slope? Well, I use my slope formula. Slope, or m, is equal to y2 minus y1 over x2 minus x1. And remember, we discussed this, how to do it. We have an xy value here. We have an xy value here, but what you have to do is label one of those x1, y1, and one of them x2, y2. And I typically work from left to right, x1, y1, x2, y2. And I work from left to right because I remember when I was in kindergarten and I was learning how to read, they said read from left to right. So that's what I typically do. However, if I made this value x1, y1 and this value x2, y2, I would still get the same slope. So it's important that you know that. Alright, so I'm going to find my slope. So I have slope m equals y2 minus y1. Well, y2 is 2 minus y1 is 2 over x2 is 6 minus x1 is negative 5. Well, 2 minus 2 is 0, and this becomes a plus, and that's 11. Now, something else we talked about last week, that any 0 divided by any number is 0. So in this case, m is going to be equal to 0. Now remember something else we talked about. Remember we said if we have 0 divided by 11, this is 0. But if we have 11 divided by 0, this is undefined. Very important, which means this is a vertical line, and we're going to talk more about that in a minute. And this is a horizontal line. Okay? Alright, so continuing on, my slope is 0. Okay? So right now I have y equals 0x plus b. I have to know what b is. So I'm going to do the same thing I did last time, where I took this point and I plugged the x for x, the y for y, and solved for b. But this time, since I'm given 2 points, all that means is I can pick. Excuse me, I can pick which one I want to use. And I'm going to pick this one because they're both positive. I prefer working with positive numbers over negative numbers. So my y is 2 equals 0 times x, which is 6, plus b. Well, this one's easy. 2 equals 0 times 6 is 0 plus b, which means that b is equal to 2. Now, some of you may not have wanted to show all those steps. That's fine. I prefer you show the steps to make sure you get a thorough understanding of it, but here's how we get b is equal to 2. So I simply write my equation. Y equals, my slope is 0, 0x plus 2. Now this is kind of redundant. You don't have to write 0 times x because 0 times anything is 0. So what I have is y equals 0 plus 2, or y equals 2, which we're going to talk about in a second. This is my answer. We're going to talk about in a second. This is a horizontal line with slope 0. But that's how that works. Follow through all your example problems and rewind this if necessary. Section 4.5 is something new. Point slope form of a line. We have a new formula here. Instead of y equals mx plus b, I'm given y minus y1 equals m times the difference of x minus x1. And it says m is my slope, which is good. That's what I've been talking about. So m is still my slope, and x1, y1 is just a given point on the line, and it says non-vertical line. So just kind of like in your slope formula where you have y2 minus y1 and x2 minus x1, these are kind of the same thing. It just means it's this x1, y1 is just a point on the line. Let's take a quick look at an example here. Write an equation in slope point form. This should be point slope. It should say point slope. Write the equation of the line passing through -2, 4 with the slope of 1/3 in point slope form. Point slope form. If you see this, just know that that's point slope. And I copied and pasted in from our lesson, so you might see that in some of the problems, but it's always referred to as point slope. Okay, and the reason it's called point slope is because when you're given a point and a slope, you can use this form of a line. And we're going to talk about, well, why do we use this in a minute, because we're also going to talk about another form of a line, and we're going to talk about some times where it would be more advantageous to use one particular form over the other. But if I want to rewrite my formula, which like I said before, when I'm working with something new, I always recommend doing that. So point slope is y minus y1 equals m times x minus x1. Well, I'm given my slope 1/3. So that's going to go right there. Now, remember before when we talked about y equals mx plus b, I said that the y is going to be there and the x is going to be there? The same for this. This y is going to be there. This x is going to be there. So I can go ahead and write those down. Okay? Now all I have to do is take my point I'm given, the x1, y1, and plug it in. Well, my point is here. So that means x1, that's this -2. So that's going to go right there. And this y1 is +4. So that's going to go right there. Now remember, you're bringing these signs, this minus sign goes there, this minus sign goes there. Bring your signs down and do just like I did. Plug in your slope, x minus, y minus. And then plugging exactly the point. Notice how my x value was -2. I plugged in that -2. Now I can simplify. Y minus 4 equals 1/3 times x plus 2, and I can be done right there. This is the point slope formula line, which is very easy just when a question asks you to write something in point slope form, because all you're basically going to do is plug in the m and the x1, y1 and simplify any signs like a minus and negative becomes a plus. That's it. And I know that's new. It's something we haven't discussed before, but hopefully you remember when we talked about the pace chart last week. Of each section, it talks about reading and taking notes and how important that is to do that. Hopefully you've been doing that, and this isn't too new, and hopefully this example helps you out. Let's move on. Okay, section 4.6. What form will we use, or which form will we use? Well, we know we have the slope-intercept form, y equals mx plus b, where m is our slope and b is the y-intercept. Then we just now learned the point-slope form, where m is still my slope and x1, y1 is a given point on the line. Now we're going to talk about standard form. It's AX, capital AX plus capital BY equals C. It says where A is greater than or equal to 0. What this means here, where it says A is greater than or equal to 0, all you need to know is that means that A can't be negative. Okay? This A out front here cannot be negative. A and B are not both 0, and A, B, and C are integers with the greatest common factor of 1. And something to remember here, maybe making this easier, is no fractions. Okay, so we don't want to have fractions, and I'm going to show you an easy way to get rid of them if you do. Okay, now a horizontal line. These are special considerations, and it's kind of what I was talking about a minute ago. A horizontal line is when you have y equals just a y-intercept, b. Remember, that's the y-intercept. Whenever you have y equals just the y-intercept, this is a horizontal line, which means your slope is 0. A vertical line, remember horizontal was from left to right, vertical is up and down. Well, that wasn't very up and down. Up and down. And vertical line, your slope is undefined. That's going to be where you have 0 on bottom of your slope. And you say, well, you can't have 0 on bottom, so that's undefined. Okay, those are two special considerations, and that's something that you do need to know. Let's take a look at this example here on the bottom. It says, find the standard form of the equation. So I have a line passes through the point 41 and has a slope of negative 2/3. Now, whenever you're writing an equation of a line in standard form and they give you the point and the slope, what we want to do is we want to start off and we want to use point slope. Okay, so we're given this point, 4,1, and we're given the slope, m is negative 2/3. And so what I'm going to do is I'm going to start off with point slope, which is y minus y1 equals m times x minus x1. Now pay very close attention to what we're doing. What I'm going to do, just like I did before, when I'm writing the equation in point slope form, is I want to sub in the m for my slope, negative 2/3 times x minus x1 is 4 equals y minus y1, which is 1. Now, if I was just being asked to write the form of the line in point slope form, I would be done. But I want standard form. Now let's take a look at standard form here. All I have here, A, that's just going to be the number in front of x. B is just going to be the number in front of y. And C is my number with no variables. So all I'm really doing here is I'm moving my number with no variables, otherwise known as the constants, to the right by itself. I want my y's on the left and I want my x's on the left, and I want my x's to come first. Remember, A cannot be negative, and I can't have fractions. And that's that. So let's take a look at what I have to do. Now, what that means is I want to move my x's to the left, I want to move my constants to the right, and I want to leave my y's on the left. So what I'm going to have to do is distribute this negative 2/3 by multiplying it to the x and the minus 4. That's the first thing. Negative 2/3 times x is negative 2/3 x. Negative 2/3 times negative 4 is positive 8/3. How do I know that? Because I have a fraction being multiplied with a whole number. I make this whole number a fraction by putting it over 1. When I multiply fractions, it's top times top and bottom times bottom. Now, something you could do in your calculator is negative 2/3 times 4, and that would give you a decimal. Okay, now how you turn that decimal into a fraction on your TI-84 or 83, you would hit math and enter twice. You do that, that'll turn a decimal into a fraction. So there's a little calculator help for you. But that's how I would do it. Top times top, bottom times bottom, negative times negative is positive, 2 times 4 is 8, 3 times 1 is 3. Bring the rest down. Now I already know that most of you are thinking, I do not like fractions. Then you're going to love standard form because we can't have fractions. Okay? Where it says A, B, and C must be integers, that means no fractions. Okay? No fractions. How do I get rid of fractions? Well, here's how I do it. Notice I have 2 fractions in my entire equation. Looking at the whole thing, I have 2 fractions. And those fractions have a common denominator of 3. If I want to get rid of the fractions, which I do, multiply the entire thing by that denominator. So I have to distribute this 3 to the y, to the minus 1, to the negative 2/3, and to the 8/3. So 3 times y is 3y. Easy enough. 3 times minus 1 is minus 3. That's easy enough. Well, what happens when I multiply this 3 times negative 2/3? It's simple. This 3 just goes away and I just have negative 2. And don't forget my x, because my x goes there with that negative 2/3. Same thing it happens when I multiply the 3 times 8/3. What happens? This 3 goes away and I get plus 8. It's kind of like before, and I'll show you over here. If I'm multiplying 3 times 8/3. We'll use just 8/3. Well, what happens is I have to put this over 1. And if we talk about cross-reducing, when we multiply fractions, we can cross-reduce. These two 3's have common factors of 3. 3 goes into 3 one time. 3 goes into 3 one time. Well, look what happens. 1 times 1 is 1 on bottom, which means that these go away. And so if it helps you out, if it makes it any easier for you, multiply the whole equation through by the common denominator. When you get to the fractions, the only thing you have left is what was on top, the negative 2x and the 8. Now I have an equation with no fractions. All I have to do now is move my constant to the right and move my x's to the left. So constant to the right, I'm going to add 3 to both sides. This goes away, bring the rest down. 3y equals negative 2x plus 11, because I can't add the 3 to the negative 2x, they're not like terms. My like terms are the 8 and the 3. 8 plus 3 is 11. Now I want to move my x's to the left, add 2x to each side. This cancels, bring everything else back down. 2x, and I want that first because I have x's first over here. Plus, and it's plus because the 3y is positive. 3y equals 11, and I'm done. And I know you're probably thinking that was a lot of work, and this was something new. Look at this example more than once if you need to. This is the way they all work. They all work this way. I'm done because I have my x's plus my y's. This could be a minus sign, equals my constants. Now something else. This a, this 2 in front of x here, which is a, it's the number in front of x, cannot be negative. If this were negative, what you would do is, just like you multiplied the entire equation by 3 up here, you would multiply the entire equation by negative 1. And that would just essentially change every sign in the problem. Okay, so again, make sure you're reading and taking notes, and make sure you view this example and do your very best with this and with it, and let me know if you have any questions. And finally, we're going to talk about the last two sections together, parallel and perpendicular lines. And the main thing you need to know about parallel and perpendicular lines when we're writing equations is that parallel lines, slopes are equal or the same. Okay? In perpendicular lines, slopes are opposite reciprocals. Now, what does that mean? Opposite reciprocals. If I have a fraction, let's say it's 1/2, opposite is dealing with the sign, positive or negative. So this is positive, so the opposite would be negative. Reciprocal means you flip the fraction, flip it. So 1/2 flip becomes 2/1. And negative 2/1 is just negative 2. So what that means is that negative 2 is the opposite reciprocal of 1/2. Let's look at another. Let's say my slope was 3. Well, matter of fact, let's say it's negative 3. Opposite would mean that it's going to be positive now. And reciprocal means I have to flip it, but it's not a fraction. But that's okay because I can make any number a fraction by putting it over 1. Then I flip it and I get 1/3. So negative 3 has an opposite reciprocal that is 1/3. Opposite reciprocal. Okay? So parallel lines have slopes that are the same, means they're equal. Perpendicular lines have slopes that are opposite reciprocals. Let's look at a couple of examples. Example 1. It wants to know, is this parallel or perpendicular or neither Two equations that represent two lines on a graph are 2x plus 4y equals 6 and 4x plus 8y equals 20. Are these lines parallel, perpendicular, or neither? In other words, it's asking, are their slopes the same, opposite reciprocals, or neither? And in order to be able to do that, notice the two equations that I'm given, they're both in standard form, which is not very beneficial for me because I want to look at the slope. And to look at the slope, I want to be able to see these two lines in y equals mx plus b form. Because if I have it in this form, the only thing I'm concerned with is m, my slope. So in order to get these in that form, I have to isolate y. I start by subtracting 2x from each side. This cancels, bring the rest down. 4y equals negative 2x plus 6 divided by 4 everywhere. This goes away. Y equals, I don't even care about my y-intercept. I'm only concerned with my slope. Negative 2 over 4, which is negative 1/2. My slope for this line, m, is equal to negative 1/2. Let's take a look at this one. Subtract 4x from each side. This goes away, and I bring the rest down. 8y equals negative 4x plus 20 divided by 8, divided by 8, divided by 8. But I'm not concerned with this because of the fact that I only want to see my slope. The 8's cancel, and I get y equals negative 4 over 8 is negative 1/2. This, 1/2 x. My slope here is negative 1/2. And my slope here is negative 1/2. So my slopes are the same, which means they're parallel. The answer here is parallel. Okay? So again, when I'm looking for parallel or perpendicular, I'm only wanting to see the slopes. And sometimes they're going to give us some problems like this in standard form where it seems like a pain to be able to put them in y equals mx plus b format to find the slope. But think about it this way. It's good practice. We can always use good practice for isolating variables. Let's look at the second example. Here it says, finding a parallel line through a given point. So we want to find a parallel line. Write the equation of the line that passes through this point and is parallel to this line. Write the equation in slope-intercept form. So my answer is going to be in this form, y equals mx plus b. And the good news is they gave us the line it's parallel to. I want a line that's going to go through this point and is parallel to this line. And I'm going to write this plus 6 over here so we can see it better. Y equals negative 2x plus 6. I'm not concerned at all about this y-intercept. The only thing that I care about is this. My slope is negative 2. And if it's going to be parallel, that means my slope in my new line, right here, I already know this is going to be y equals negative 2x plus b. I already know that because I'm writing the equation of a line that's parallel to this line. And if it's going to be parallel to this line, it has to have the exact same slope, which is negative 2. Now I have a point, and I'm going back to what I did earlier in the day. I have y equals negative 2x plus b. I can sub y for y and x for x and solve for b. Y is 3. 3 equals negative 2 times x, which is negative 5, plus b. And I can solve for b now. So I have 3 equals negative 2 times negative 5 is positive 10 plus b. Subtract 10 from each side. This goes away. 3 minus 10, use your calculator, gives you -7 is B. So my y-intercept is B. Therefore, the equation of my line in slope-intercept form, y equals mx plus b, is y equals -2x minus 7. Done. Again, finding a line that's parallel, my slopes are the same. There's my slope. It gave it to me, -2. Gave me a very convenient format so I can already see my slope. If I go back to the previous example, it gave me the standard forms, which weren't very convenient because I had to do some work before I could find my slope. Here, they basically gave me my slope. Then there's my point. I'm done. Final example. Finding a perpendicular line. That means we're going to be looking at opposite reciprocals here. Write the slope-intercept equation of a line. Still looking at, that's y equals mx plus b. That passes through this point and is perpendicular to this line. Okay, perpendicular to the graph of this line. Well, this is another very beneficial form here. I already know my slope here. This slope right here, m, equals -1/2. But I want the equation of a line that's perpendicular to this, which means I need a slope that is opposite and the reciprocal of this. Well, the opposite reciprocal of this, the opposite would be positive. The reciprocal would be 2/1, which is 2. So the slope of my new line, I already know, y equals 2x plus b. Because I'm perpendicular, my slope was -1/2. Opposite reciprocal, because it's perpendicular, becomes 2. 2/1, which is 2. Then I just do the same thing. Y for y, x for x, solve for b. Y is 1. X is 4. Solve for b. 1 equals 8 plus b. Subtract 8 from each side. -7. 1 minus 8 is -7 equals b. My equation, y equals 2x minus 7, and I'm done. So these are probably new topics for you. Make sure you're taking notes. Make sure you're reading through the sections. Definitely make sure you're rewinding this video if you need to see the example again. And hopefully this helps you out quite a bit.